All right, so we're going to draw what looks like a cubic graph. Okay, nice and smooth. But when you get to that last dot, instead of the graph coming right back down, you're just sort of going to curve it up. Okay. Right. Alrighty, here we go. Highlight. Highlight. Color code. Dash marks, dotted line, doesn't matter. Okay, we're just going to identify some pieces on this graph. So potentially 3 different things we're going to identify. First thing I'm going to look for, okay, f prime of x is positive. I want to know where on this graph that f prime of x is positive. All right, so I'm thinking, okay, these are the things that I can interchange with f prime. Because I'm looking at a picture, I want to go for the one that's a little more visual, which is tangent slope. So instead of saying f prime, I'm going to say, where is tangent slope positive? And that's what I'm going to look for. Right? So I take my very nifty tangent line and pencil, and I just drag my pencil across the graph, and I'm looking at the slope of the pencil, and where is the slope of that pencil positive? That's what I want to know. Right? So you have to kind of envision the tangent line. I'm going to do this one pink. Okay. Everywhere here, the tangent line has a positive slope. Some places steeper than others, right? Not very steep up here, but it's still positive. Okay. And here. And here, right? Increasing positive slope. Okay, next description. F prime of x is negative. Okay. I lost my green highlighter. I mean, I have green. I just want the highlighter. Oh, well. Okay. All right. Here we go. Negative. So where is the tangent slope? Negative. That looks like a negative sloped line. Oh, that's right here. Okay, that's the part that has a negative slope. At every single dot or tangent line, you have a negative slope. All right, now for the last one. F prime of x is 0. Okay, so let's think. Tangent slope. So tangent slope is 0. What kind of line has a 0 slope? Don't yell it. What kind of line has a 0 slope? If I'm going to like draw it, what does it look like? So positive is like this, negative is like this. Yes, yes, thank you. Okay. 0. That's a 0 slope. Okay, so, oh, wait. Now let's drag that tangent line and let's see what happens. Okay, so positive, 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 0. negative, 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 negative. How do you get from, on a number line, negative numbers to positive numbers? What goes between them? 0. So if you're going to switch from a positive slope to a negative slope, 0's going to be between them. Okay? So right here, 0, 0. This other one's a little tricky. Okay? See how the graph levels out? That's a 0 slope. And then it goes back up again. So this point right here, that is a 0 slope. Now, I'm going to write another word here. Horizontal tangent line. Because a horizontal line is the thing that has a slope of 0. Okay. So all we did here is look at what kind of slopes our tangent line would have as we look at the original graph. Okay, right? Visuals. Now we're going to do the more complicated vocab. I just need more space. You guys are probably good. All right. Okay. Differentiate is a verb. Means it's an action. It's an action. It means to find f prime of x, otherwise known as the derivative. Find the derivative. Okay, it's an action word, right? You know how sometimes your directions say factor. Factor is an action. Differentiate is an action. It is telling you to do something. It is telling you to find f prime of x, which is interchangeable with the derivative. The way the questions are worded are going to tell you what you're supposed to do. Okay, so there's a lot of words that we can switch back and forth. So we're paying attention to the vocab. Derivative and differentiate kind of sound similar, sort of. Okay, they're connected. All right. Next word, differentiable. Kind of connected to differentiate. Okay. Adjective? Grammar is not my strong suit, guys. Okay, differentiable. The derivative exists. Exist is a hard word to understand. Okay, so I'm going to give you a second explanation. Differentiable means there is a tangent line with a number for the slope. Okay, that's what differentiable means. It means that there is a tangent line. So as I'm looking at the picture, there is a tangent line and it actually has a number for a slope. A number is negative, positive, or 0, right? We just looked at that on the graph. That's what I mean. Like, there is a tangent line and it actually has a slope. Okay. So we're going to answer 2 questions with these vocab words, and then we'll pause and we'll practice. When is a graph differentiable? Okay. When does the graph have a tangent line with a number for the slope? Okay, so I'm going to think of pictures, right? I'm thinking of pictures because this is all graphically right now. Okay. Yes, looks reasonable. Okay. Maybe it looks like this. Okay. Maybe it looks like this. Okay. Can you picture a tangent line at every point? Yes, right? When is the graph differentiable? When you can picture a tangent line that actually has a slope. Okay. Okay. So all of these graphs are smooth, and continuous. Smooth and continuous. When is a graph not differentiable? Okay. So when is there no tangent line, right? No tangent line, because I'm transferring this definition to something visual. When is there no tangent line and, okay, think way back to Algebra 1. There's 4 types of slopes. Positive, negative, 0. What's the other one? Yes, okay, so you see how undefined is not included here? Because undefined is not a number. So no tangent line or undefined slope, because existing means there's a number for the slope. That's what existing means. So we have to take into account, or maybe I see an undefined slope. Okay. So we have 2 things that make a graph not differentiable. The first one is not continuous. Continuous. Okay, we know what not continuous looks like. Point, jump, vertical asymptote, right? All of those things. A graph is not continuous when it is, a graph is not differentiable when a graph is not continuous. Okay? Point, jump, or vertical asymptote. That's what I'm looking for. Okay? Okay, second option. Continuous, but not, right? Not differentiable. Okay. Corner. This is a sharp turn. Okay? Notice up here I said smooth. This is not smooth. Corner in the graph. Now, as I envision my tangent line, right, because that's what I'm thinking about, can I put a tangent line on this graph? Well, this line goes like this, and this line goes like this, and maybe my tangent line goes like this. But notice that it can teeter, and I'm still only touching one point. So which one's my tangent line? Can't say all of them. There's one tangent line. Okay? So because that tangent line is teetering, there is none. Okay? Because it's not smooth. So when I think of this right here, because the line teeters, right? The tangent line sort of balances at the top of that point. There is not one tangent line. Okay? Not differentiable because the tangent line is teetering or balancing at the top. Okay, this one is called a cusp. A cusp it's just curved. It's kind of the exact same thing as the corner, but it's sort of curved as it's approaching that one point. Okay? Same reason. Because the tangent line sort of teeters right here at the top. Now, I'm looking at this, and I'm like, okay, I follow the tangent line. The tangent line, right, as I follow the curve, the tangent line looks like it might be straight up and down. It still doesn't work, okay? All right, last one. Vertical tangent. I'm going to draw what appears to be a cube root graph. Okay. And despite my best efforts at the drawing, okay, that is a vertical tangent because the slope is undefined. Okay, so I'm going to zoom out a little bit. We'll just sort of look at everything we did. Okay, here are your two questions. When is a graph differentiable? Smooth and continuous. Okay, notice how this picture is smooth and continuous, but the slope is undefined. Okay? So smooth and continuous, tangent slope is actually a number, right? You got to figure out, how do I tell these things apart? Smooth, continuous, tangent slope is actually a number. Ah, undefined's not a number. That reminds me to put it in the not differentiable category. Okay, so the first thing I'm doing here is the graph is shown, m is the slope of the tangent line at x equals 5.75. So I need to look at that spot on the graph, okay? Because remember, this is all visual, so it's what do you see? So at 5.75 is like here, okay? I'm going to sketch my tangent line. Okay, about like that. Now, it should be a little closer to the curve, okay? And so I'm going to look at it. What do I think the slope of this line is? Just take your best guess. I'm just looking for some points here. 3, 3, 6. So the slope is rise over run. It looks like my slope is 1/2 negative, right? Negative. Check those pluses and minuses. Okay, so now I go and I look. So my slope is not 0. So I'm going to cross off not 0. It's not positive. Okay? How steep is the line? It's not undefined. It's not this one. So now you're just looking at how steep is the line. The line was not very steep. It was less than, right? It's not this one. And so that leaves you here. Okay, let's click. Submit. Yay! Woo. Okay, I'll do one more of these. So we're looking at x equals 0.75. That's exactly what we just did. See, solution. I know. Okay, let's do next problem. Okay, look at the way the question is being asked. This is why you've got that vocab. This means tangent slope when x equals 0.75. So 0.75 is right here. The tangent line is a negative slope, but not very steep. Okay. Sorry, you're just going to have to look through that. Okay, not very steep. Okay, so not this one. It's not 0. It's not positive. It's not positive. So it's asking how steep is it? Compare it to a slope of 1. It was not very steep. Okay, so we're going to do this algebraically. Right? Last class, we figured out what the shortcut was to finding the derivative. We called it the power rule. So I'm going to start with a few examples. Okay. Examples. Right. And this is going to be find the derivative. Yep. Okay, so the derivative, that's the key word. Okay. The derivative can be interchanged with f prime of x. Okay. Now, this one, f prime of x, comes from Newton. Yes, Isaac Newton. Okay. It's just notation. There's a separate notation that looks like this. dy dx. Okay. The d is for delta, which is the Greek letter d, which means change. The triangle means change. Change in, wow, change in y over change in x, which is just slope. That's all it is. It's just a different notation, okay? Because we need to know which words can be interchanged so I understand the directions. Find the derivative. Could be find f prime. Could be find dy dx. Now this notation comes from a guy called Leibniz? I can't. Yeah, something like Leibniz. Okay, these two are credited with creating calculus kind of simultaneously in two different parts of the world, but they created the same thing, but they have different notations. This one is function notation. This one is not. It's the same thing, okay? They just look different. All right, so here we go. Find the derivative. Y equals 4x squared minus 5x plus 7. Find the derivative. So dy dx, usually if I see y equals, I use Leibniz notation. If I see f of x, I use Newton notation. They are switched around. They are the same thing. Okay, so we have that power rule. We have the power rule, which tells me that I take the power and then I decrease the exponent by 1. That's how I do the derivative. So we get 8x to the first. That's that shortcut that we learned on Friday. Okay, so this is the y equals. This part is the derivative. Okay, so think of this one, 5x plus 7, mx plus b. What is the slope of mx plus b? Just m. Right? Only the pieces with an x actually have a derivative. The number goes away. The vertical shift does not affect the slope. Okay, so this is the answer. Negative 5x cubed plus 3x squared. F prime of x. Okay. So my rule tells me to take the exponent and multiply it in front. So minus 15 x squared plus 6x to the first. You do not need to write the first power. This is the derivative. Just going to put a little box around this. Sort of important. Okay. All right, 3. Find f prime of 3. Okay, so I'm sort of adding a piece here. Find f prime of 3. So I'm going to translate this. We know that f prime is tangent slope at x equals 3. Right? Because I want to know visually what this is asking me for. Okay? F prime and tangent slope interchangeable at the x coordinate of 3. Okay, so here's my f of x. 3x minus x squared. Okay. I want to know the tangent slope at x equals 3. So the first thing I'm going to need is the derivative. Okay, so the power of 1 decreases to 0, so no more x. 2x to the first. Step number 1. Yes, now I plug in 3, okay, because this is the derivative. This is the equation that describes tangent slope. That's what the derivative is. I want the tangent slope, but I want to know what it is at 3. So you plug in 3. Okay. Okay, there's a lot of vocab because the vocab tells you what you are doing. The algebra is not the tricky part. It's the vocab and knowing what the question is asking you to do. Okay, so we're going to do one more like this. Okay. And then we'll put some of it together. Okay. Find dy dx at x equals -2. Okay. You're like, oh, that looks kind of funny. Yeah. Find the derivative when x equals -2. So this is tangent slope, right? So I'm translating. This thing is tangent slope at x equals -2. So look at the parts that I'm exchanging. For words that mean something graphically, find the tangent slope at x equals 2. Right? I don't have the parentheses to plug in the -2, so I just write it here. That bar just sort of stops me and says, okay, now plug in. All right, y equals 4x plus 7x squared minus 1. Okay, dy. Notice it's not in function notation, right? So dy dx is 4 plus 14x, and the number goes, there's no x's, so it decreases to 0. All right, dy dx, when I plug in -2, looks like this. That's what that means. It's just plug in the number. That's all that notation means. 4 minus 28. So the tangent slope is -24. All right. You're so close. E, C, D. The tangent line. Okay. Tangent line. You need a point. I'm writing really fast. I'm going to slow. And you need a slope. Okay. Point and slope. Y minus y1 equals slope. X minus x1. That's the equation of a line. That is the equation of an Algebra 1 line, maybe an Algebra 2 line, definitely a pre-calc line. So now we're going to make it calculus. Point, okay? Points are still just points on a graph. Slope. So we're going to make it a tangent line. That is tangent slope. The only thing that makes this a tangent line is that you use tangent slope. That's it. It's the only thing. Okay, so let's put these two things together. Y minus y1, slope tangent. Okay. So the only thing that made this calculus is the vocab tangent slope. The other steps, equation of a line, are like review. Okay, so here we go. That's the equation of a tangent line. Why? Because it's using tangent slope. Okay, tangent slope. Exchanges with f prime of the x coordinate, right? Plugging in the number. Maybe it's dy dx when you plug in. Okay, tangent slope is a number, right? It's the slope of a line, positive, negative, or zero. That's it. Okay, so tangent slope is represented by f prime of x or dy dx. Kind of like those examples we just did where we found a number. So our last example is going to be writing the equation of a tangent line. So here's your formula. There's your tangent line. Okay, I need to know this. Okay, that's the thing I'm going to be filling out. I need a point and a slope in order to use that formula. That's what we're going to be trying to find. Find equation, EQN equation of tangent line at x equals 2. Right, there's your f of x. Right, that's just my formula. Just writing it down. That's the equation of a tangent line. I decided what my answer is supposed to be. The equation of a tangent line. Okay? So there's the calculus part. Equation of a tangent line is this. Okay? I know that x equals 2. That's the only thing I know. All right. I need a point. How do you write the equation of a line? You need a point when x equals 2. How do you get a point? The same way you got a point for the last 3 years. You plug it in. Okay, so there's my point. How do you get a tangent slope? I don't know, check example 3 and 4, because that's what we did. You found the tangent slope. Now we're just sort of putting things together. tangent slope is the derivative and I plug in the x coordinate, right? I need tangent slope when x equals 2. So I plug in 2. I'm just plugging it into the derivative because the derivative is the thing that tells me what the tangent slope is. Okay, so the slope, tangent, is 1. All right. Point and slope. Put a box around it. Done. Okay, so tangent line, tangent slope, right? That's the calculus part, right? It's the vocab. I was asking about a tangent line, so I know that I need tangent slope, which I know is the derivative. That's the calculus part. The rest of this, finding a point and writing the equation, that's other stuff. Okay, so my point is -1, 3. Okay, because I plugged it in here to the original. In order to find slope, we need the derivative. Okay. 6x squared minus 4, and then the 1 turns to 0. But we need the tangent slope, which means we plug in -1. Which is 2. Okay. 1. Yeah, you're good. Okay. Right, so I use my point and my slope. Here you go.